Welcome to National Weather Service Billings Severe Weather Spotter Training Series. This presentation will provide information on wind and hail ahead of the severe weather season. In the last session, we looked at the updraft in a storm. Now let's take a look at the impacts of downdrafts. You will often hear the term microburst, or straight-line winds, used to identify these bursts of severe winds from thunderstorms. These winds are different from tornadoes, as the wind and associated damage are basically all in one direction. Microbursts can be wet or dry, depending on the amount of precipitation that occurs with these high winds. These severe winds occur as rain-cooled air rushes down from the base of a storm. This air can accelerate at a high rate of speed and slam into the ground, producing winds in excess of 60 miles an hour. Sometimes you might be able to identify a microburst from afar, as seen in the photo. Notice the curling, or rolling, of the precipitation on the edge of the rain area. This can be visible as the air slams into the ground. While microburst winds are more common than tornadoes, the damage associated with these winds can be similar to weak tornadoes.
Photographer and monsoon chaser Brian Snyder was taking time-lapse footage of a storm in the Tucson area when he captured this incredible weather event, a wet microburst. Microbursts affect an area of no more than 2.5 miles across, and they occur when a cooled, heavier column of air sinks rapidly in the middle of a thunderstorm. As the air hits the ground, it spreads out with great force, often generating winds of over 150 miles per hour. In the case of a wet microburst, it also brings crashing rain, often described as a rain bomb.
In the Bighorn Mountains back in 2015, a thunderstorm moved through the area with an associated microburst. Winds were estimated at 90 to 100 miles per hour, which caused significant damage. Not only was there tree damage, but 2 campers were destroyed, along with severely damaging 2 others. Notice the trees in the bottom right picture were uprooted in the same direction. This is a good indication that it was due to a microburst rather than a tornado, yet the damage is equivalent. Baker, Montana had a microburst back in 2014 with winds gusting up to 64 miles per hour. The county fair was in progress at this time. The winds blew over tents, damaged and uprooted trees, and produced damage to a tin roofing at a local firehouse, again showing the power and danger of microburst winds. Downbursts are also dangerous for aviation. If planes were to fly through a downburst, it would cause the plane to suddenly lose or gain altitude quickly. The National Weather Service has been able to provide the FAA with heads up about strong storms so that they have the opportunity to divert planes around these storms. Let's move on to hail. The largest hail will occur just off to the side of the updraft of a storm, where strong winds aloft push rain and hail away from the updraft, allowing it to fall to the ground. In this picture of a classic supercell thunderstorm, the left side of the storm has a flat rain-free base. The base is rain-free because the air is rising rapidly upward and not allowing precipitation to fall to the ground. But it's just to the right of the area. You can see a darker area under the cloud. This is where the precipitation is falling. It's just off to the right of the rain-free base, where the largest hail will most likely occur. Hail is the most destructive element associated with severe thunderstorms, even more so than tornadoes. Hail can cause nearly $1 billion in damage to property and crops annually. The costliest U.S. hailstorm was back on April 10, 2001, along the I-70 corridor near Kansas, Missouri, and Illinois, which totaled $2 billion. When it comes to reporting hail, refer to common objects such as quarters or golf balls when estimating sizes. By using common objects that we can all relate to, it makes the phone calls from our spotters quick and easy to understand. However, avoid using the term marble-size hail. The trouble with describing hail as marble size is that there are so many different sizes of marbles. When reporting hail, always report the largest size that you see, not the average. It only takes a couple large hailstones amongst a lot of small hailstones to produce significant damage. The world record for largest hail was set on July 23, 2010 in Vivian, South Dakota. This hailstone had a diameter of 8 inches and weighed 1.94 pounds. The size and speed of this hail produced a large hole in the ground as seen on the picture on the right. Here's a video from Colorado Springs back in 2018 that caused significant damage to a golf course. Hailstones within severe thunderstorms fall between 25 and 40 miles per hour, increasing in speed as the hail diameter increases. When hail reaches 4 inches in diameter, they could be falling at about 100 miles per hour. Make sure you take shelter away from windows when hail begins to fall. Let's move to a local example in Billings from 2016. Baker, Montana was hit with a severe thunderstorm that caused significant damage back in 2016. Windows in both homes and on cars were broken, and siding on houses was torn off. Many of us can remember the storm that moved through the Billings area on August 11, 2019. Hail up to 4 inches in diameter, along with wind gusts to 74 miles per hour in Moult and wind gusts of 71 miles per hour in Billings were recorded. Large hail combined with severe winds is an especially dangerous combination. As seen in these pictures, significant damage was done to siding and hail blasted through windows. Significant damage was reported along the storm's path that stretched from Big Timber through Billings. Thanks for learning about wind and hail with us. Join us for our next video on tornadoes. Stay safe, everyone.